Hi everybody, before we start the lesson 19 problem set, I wanted to talk a little bit about the diagonals of a kite. So I went ahead and drew the diagonals and measured them. And so here's what I found. My diagonals do intersect in my kite. When I measured them, I could see that the diagonal going from point I to point E was not bisected into two equal pieces. But I did see that my diagonal from line K to T does bisect. I measured these angles, and all angles are 90 degrees where those lines, those diagonals intersect. So kind of thinking about a kite, diagonals are not the same length. The diagonals meet at 90-degree angles, so they are perpendicular. One diagonal bisects the other, which is this one, but the other diagonal is not bisected because they're different lengths. So if we really start to think about the attributes of a kite, here's what we know. It's a quadrilateral. With equal adjacent sides. There's a kite, a quadrilateral with equal adjacent sides. Okay, so we're going to switch over to the problem set because I do want to be able to show you some different way kites could be drawn and not have my book fall off. Okay, so for lesson 19, it says draw the figures in each box with the attributes listed, and then if your figure has more than one name, write the name in the box. Okay, so this first drawing is it wants to draw a rhombus with two right angles. Now what this means is it can have more than two right angles. It just has to have two right angles. So really, and you guys, I'm gonna do this freehand, which I know, but I want to save on time because I want to show you. So if this was drawn perfectly, all four angles would be 90-degree angles, and these would all be the same length because we know in a rhombus it has to have the same length. So if I'm thinking of all the names that this could be, this is a rhombus. We know that when a parallelogram, I'm already naming it. We know that a rhombus is also known as a square because of those equal side lengths. We know that a square is also a rectangle because of the 90-degree angles. We know that we have two sets of parallel lines, so it's also a parallelogram. We can call it a trapezoid because it has at least one pair of parallel lines, and because it has four sides, it's a quadrilateral. So this one drawing has 1, 2, 3, 4, 5, 6 names. Okay, so, oh, and I left off, we can also call it a kite because it's a quadrilateral that has two sides that are adjacent that are equal to each other. So it's also called a kite. So if we did a kite with all sides equal, but let's say not 90 degrees, okay? So let's say these were larger angles, like this was 110, which would make this 110, which would make these 70. Then we would have a kite, because again, these are adjacent sides that are the same length. We could call this a rhombus. We couldn't call it a square or a parallelogram because it doesn't have those 90-degree angles, but we could call it a parallelogram. We could call it a trapezoid, and we could call it a quadrilateral. A kite with four right angles. I hope you're understanding this because this is kind of cool that a kite could be turned this way because a kite just needs adjacent sides to be the same length. These two sides are the same length. These two sides are the same length. And if this had 90-degree angles, we know it's a kite, but it's also a square, which means it's a rhombus, a rectangle, a parallelogram, a trapezoid, and a quadrilateral. So I hope you're starting to see the connection that a lot of these shapes have more than one name, but it's those tiny details in their attributes that make them different. So a kite with two pairs of adjacent sides equal, the pairs are not equal to each other. So that would kind of look like, we could do it this way. We're going to say those are the same length, and then these are the same length. So we can obviously see that we have different side lengths, but we have, these are the same, these are the same. And if I were to measure these, which if this was drawn precisely, we would see that these two angles would be the same. Because that's also something, a feature we see of a kite. And so we could call this a kite, and then we could also call it a quadrilateral. Why couldn't we call it a parallelogram? And I'm hoping someone at home watching this video is saying why we couldn't call it a parallelogram. There are no parallel sides when we draw a kite like this. Okay, so I'm gonna flip the page because I really do like to think about the properties. I think that's really, really, really important. So if we wanted to list properties shared by all of the squares that we've worked with today, 4 sides of equal length, four 90-degree angles, opposite sides, parallel. And then we have our diagonals, perpendicular, bisectors. And remember, when they're perpendicular bisectors, that means that when they cross each other, they form 90-degree angles. Okay, so list the properties shared by all of the kites that you worked with today. So kites have 4 sides. They have 2 sets of our new word we learned today of adjacent sides that are equal in length. And we're going to put 1 set of opposite equal angles. This also has diagonals at right angles, but they're not perpendicular bisectors. I'm not going to write that down. Okay, so when can a rhombus also be called a square? When it has what? They both are going to have equal side lengths, but what makes a rhombus a square is when it has those 4 90-degree angles, or we would say those 4 right angles. When can a kite also be called a square? So this needs